Alright, welcome to my presentation, Building a CLI in Go. Let's get into it. First I'm going to tell you a little summary about my presentation. After this I will introduce myself. Then I will tell what a CLI is, why I use Go for this. Then I'm going to get into our CLI, which I'll get to later. We're going to improve that, and after that there might be more. Alright, who am I? I'm Casper Spruit. I'm a CLI enthusiast, and I work at Weave as a developer. I studied media technology at in Rotterdam, and I've added a quote for you guys, like you're supposed to do in every presentation. It's also in the team of CLI. I'd like you all to take a moment to read it. Alright. As I told you guys before, I work at Weave. I work in a team on an innovative energy company. It's very awesome. We work with technologies like Kubernetes, NATS, and mainly Go. If you're interested, feel free to check us out. We're always looking for new people. So, what is a CLI? Can I see some hands for who knows what a CLI is? Alright, almost everybody. A CLI is a way to interact with your software through the terminal. So normally if you write software you would have a button or an event that would make an action happen, and with CLI you're communicating with your software through the terminal. If you don't know what the terminal is, it's what opens up if you type in CMD on Windows. Yes. Let's continue. Some examples of CLIs you might know are CD, which is used to change your directory in Linux, or ls, which is used to show the files in the directory in Linux. And more of you guys might know npm, which is used for managing npm scripts and packages. There are also some CLIs you might already know that are written in Go. First off, Go itself is a CLI. You can use it to run Go scripts, to build Go scripts, and to manage your packages. You might also know Docker Compose, which is used to compose Docker. And if you take that a step further, you get to Kubernetes, which is, its CLI is written in Go. Why did we choose Go? The funny thing is, if you run the CLI, it's very useful if your program is built to a single file. So that. Then it's also it's buildable to all platforms, which is also very useful because you don't have to rewrite your code for different OSs. Also, I think it's a single language, which is again very useful, and it's very fast. Yes, our CLI. What I mean by that is actually a way of showing you guys how to make a CLI. So when I started using Go, I found a website called Go by Example, which actually shows a Go script with an explanation next to it, which I found very nice to work with. There are also examples like Kubernetes by example, which also helped me with understanding how Kubernetes works. So I thought of doing the same thing with you guys. So let's get into our CLI. Nice. Right, is this readable? Alright. First off, I'm gonna explain a little bit what's happening here. If you use Go daily, it might seem very simple, but I'm guessing not everyone here uses Go every day. Alright. Well, first, main is the intro, point of our script. After that, we see a variable named flag, which we first notice the flag package, which is a package of Go itself used to pass parameters to your script. So for example, this one would, if you pass the option N, it would, after parsing, pass the value you passed in your CLI to the variable name. So after that, we're going to check if this variable is set and if it's not empty, because currently our script is in need of this parameter. So the next thing you see is our secret save, which I created especially for this example. I'm not going to get into how it works, but it's very safe. Also, our save has a name, so if we would have multiple saves, we can find back which save we're looking for. So at last, the name of our save is printed. That's convenient. Right, it works. Now, you just saw me use GoRun, which is one way to run your script. GoRun would be used for debugging, since it's very, well, it's quicker. I'll get to why. And it's also available to use in your project. So what I mean by that is if you have added a CLI to your modules, that's your Go package manager, and you would run it with GoRun, it would run on the same version as specified in your Go mod, which is useful if you want the complete team to use the same version. Secondly, there's Go install. Why that's not so useful for debugging is because it installs it to a global variable if your Go path is set up correctly. So you would tell the users of your software, you would tell them use Go install github.com blah blah. The next thing to know about the CLI in Go, well actually every CLI, is options. Options are, as told before, are to specify parameters to your program. So there are some very boring guidelines for this, but I think they're important. The first one being POSIX. It's a little bit older, and the main thing I took away from this is it started defining short-named options. So you just saw me use -n to pass the name of our secret save. Well, POSIX defines that with a number of extra rules, but mainly short-named options. Then there's GNU, which is a little bit newer. I think it's also more used in open source software. And they specified exactly what's in POSIX, but with some additions. The most important one being long-named options. So if you have multiple options, it can get confusing. So that's why they have long-named options, which in our example would be name. That's way more readable. Also, they define you should always have two options, which are --help and --version. --help should show you what options are available for this command or its subcommand, and --version, as you might already think, would show you the version. Well, you might have noticed that the Go flag package, which is built in, doesn't have a long-named option. So our software currently isn't compatible with GNU. So to make it compatible with GNU, we have one very simple change, which is BFLAG. So how you would use BFLAG, if you've already used flag in your software, you would just import it under the named import flag. The BFLAG package is completely compatible with flag, so it exposes the same functions, but they have one very important difference, which is the P. So if I add a P, now I can define my long-named option. So I didn't have to change a lot of code, well actually almost none. And now we can use the long int option. Alright, there's one more thing I'd like to tell you about what's inside the flag package. And since it's also in the BFLAG package, I'm just gonna leave it there. So that's what's called a flag set. So a flag set is mostly used to define different options for your subcommandos, which we'll get into later. But currently we can also use it on our main command line command. So the flag package exposes a command line variable, which is actually a flag set to your CLI, so not a subcommando. You can use a flag set to define different flags, and later you can parse all the flags from that flag set, which is useful if you want to extract this later. Also, it can now return the error. What is important to know with flag set is that you have to pass your own OSRs, and you don't want to pass the first one, since the first one is your CLI. And we should catch our error. And it still works. So the next thing I'd like to talk about is the structure of our CLI. I think there are two things to take in consideration for the structure of your CLI. And those are you creating a CLI, or are you creating something else with the CLI? So it might be a package which is also accessible through CLI, but it could also just be your project. So currently our example would only be a CLI. So I actually only need main.go and my structure for this simple CLI would be complete. But if we, for example, would have multiple CLIs, we could add them under the subdirectory cmd. And why this is useful is because now your subdirectories define the name of this CLI. So if I would go install save version 1, the CLI would be installed as save version 1. Then there's command abstraction. So what I mean by that is that if we have more than one command, we might want to abstract that to a package or a different file. I've tried to find a way that's nice for this. So this is my second example with an abstracted command. So as you might notice, if you write Go more often, it's quite the same as before, but now everything is on a struct. So the same flag set is now initiated in our constructor, but this time on the struct. And our save is now dependency injected, which is useful for something we'll try later. Also very convenient, our option is now defined on the struct. So I've used a different method, which is also in the flag package, the string var method, which now allows you to pass a pointer. The run actually does quite the same as before, but now we use the set name function on our save because since it's an interface, we can't access the attributes anymore. Alright, testing our code is also very important. Two things I'd like to take into consideration, at the least for testing our CLI, are option interference and dependency injection. What I mean by option interference is allowing us to pass different options to our CLI. So that way, if we would like to test with a different parameter, we are allowed to do that. And the next thing is dependency injection, which you should always use that in the test, I think. So also in the CLI. So let me show you my fully implemented test. Right, let's implement the test. So what I did here is I mocked my save, since it's so safe. We don't want to execute that in our test. And I used a package called mockery. I'm not going to get into it, but it's going to generate a mock for you, which I think is very useful. So this is a very simple test, but I just want to give a simple example. And for our current example, it doesn't matter what parameters we actually pass to our CLI, since our save is just going to keep it safe. So we're not going to make that very complicated. If I do this right, our test should succeed. Yes. Also, I think it's important to handle your errors in a different way for a CLI. Mainly because the users are they're getting in touch with your errors. If you write your Go software in a Docker image and you're logging, throws it in Grafana or Google Cloud, whatever, your user might not see your error, but with the CLI, your user is definitely going to see your error. So I think you should pay a little bit more attention to your error. The first thing to consider is if you pass down your error through your software, you end up in your main, if you should throw a fatal or a panic, if you want your software to stop at least. I think you should mostly use fatal for this, since it's going to stop your code from executing and not going to give a stack trace, which is mostly not useful for the user if you're building a CLI. Panic, I think, could be used in functions that can't return an error, so you don't have a choice. Then for logging, I think it's nice in a CLI to only log non-debugging logs in your main and maybe one layer up. Other logs, I think, should be hidden behind the verbose flag. Well, like I told you before, meaningful errors are important. Now you're thinking, what about subcommandos? So I also created a way to use subcommandos, multiple ones, with the flag package. So it's actually quite the same as our previous code, but now we require 2 arguments since we want to use a subcommand, and we have the find command function. So the find command function, in my case, defines a map with 2 safes, and they might look like the same safe, but the second one is extra safe since the password is way longer. So after that, we're gonna loop through our subcommands, and I just realized this doesn't have to be a loop with a map, but it is for now. And then we're gonna pass our args to the init from our subcommand. So our previous extracted command didn't have an init, but with multiple subcommands, I thought it was useful since, well, now you have multiple ways of handling your options going wrong. So if you require a flag or you have validation on a flag, you could catch it early now. And after that, the specified command is returned, and we just run it. So our CLI, by example, went to production, and I'd like to tell you a little bit more about Go CLIs, but not with our example. So if you after this presentation think that you want to know more about CLIs in Go, I have some resources for you. The first one being Cobra and Viper. These are, I think, the most known frameworks for handling CLIs in Go. Cobra wraps your commands, your subcommands, and your options in a nice format and gives you an easy way to handle and validate them. Viper actually works together with Cobra, and well, most of the time if I use Viper I have more than 4 commands, so I want to use a YAML, and that's what it's for, to pass options through a YAML. Then the thing I'm very excited about is Awesome Go. Some of you might already know Awesome lists on GitHub. If you don't, please check them out. If you scan the QR, it will open up a link of Awesome Go, which is a list of awesome resources of Go, with a link through the subheader command line, since our presentation is about CLI. Then there are 2 examples you could use, which are actually kept up to date and written in Go. The first one being kubectl from Kubernetes, and the second one from the Go debugger being Go Delve. Then I have some bonus material. So if you want to surprise your users with an advanced terminal UI, you could use a loader, a menu, or questions, which are ways to interact with your user through the terminal. I would use a loader if your program is slow or has a lot to do. This way the user knows what's happening and it's not going to Ctrl-C your program away. Menus and questions could be used if you have a lot of parameters which are getting confusing and you want to provide a nice UI to your users. Then I'd like to give honorable mention to one of the most advanced terminal UIs I've seen in Go, which is K9's. You can see it on the screen. Well, not really, but it's awesome. It's used to a few different resources in your Kubernetes cluster. You can port forward a few logs. If you use Kubernetes, feel free to check it out. Thank you. That was my presentation about building a CLI in Go.